This is Mr. Beck Does Your Homework. This is AP Physics Homework 2.4 about free fall. This is question number 5, and let me tell you, this question requires you draw a picture so you can think about what's going on. A daring stunt woman sitting on a tree limb wishes to drop vertically onto a horse galloping under the tree. So what we've got is we've got a tree with a branch on it. So here's my tree with a branch on it, and I've got a daring stunt woman sitting on the branch of that tree, and she's going to want to fall onto a horse that's galloping by, and here is my stick figure horse. There's my horse, and he's galloping, so there he goes. So I've got a horse galloping by, and she wants to fall onto the horse. So let's see. The constant speed of the horse is 4.6 meters per second. So that horse is moving along at 4.6 meters per second, and it's constant. That's not accelerating. The woman is initially 1.81 meters above the level of the saddle. So she is going to fall down 1.81 meters. How long is she in the air? So I'm looking for a time, and the acceleration of gravity is 9.8 meters per second squared. So what I know is that her initial velocity is 0. I know that her displacement by the time she hits the horse is going to be negative 1.81 meters. And I know that her acceleration is going to be negative 9.8 meters per second squared, because gravity is down towards the center of the earth, so I'm going to enter it as a negative. What I'm looking for is how long is she in the air, so I'm looking for time. So I've got initial velocity, displacement, acceleration, and time is what I'm looking for. So what I don't know there is my final velocity, so I want to pick the equation without a final velocity. What I get is that my displacement equals my initial velocity times time plus 1/2 my acceleration times time squared. Since my initial velocity is 0, this goes away. So I get y equals 1/2 acceleration times time squared. Well, now would be a good time to rearrange this equation just so that we can, since we have so many things that fall from rest and we want to know the time it takes to hit the ground, take a look at this equation and solve for t. First, I'd multiply by 2, so I would get, and I'm going to go up here, I would get 2y equals gt squared. Now I'm going to divide by g, so I get 2y over g equals t squared, and now I'm going to square root both sides. So if I rearrange, I get time equals the square root of 2y over g. This is a handy equation to have, because now every time I drop an object, I can use this equation. So for this one, how long is she in the air? Well, let me plug it in. My time is going to be the square root of twice negative 9.8. Whoops, backwards. My time, let me do that again. My time is going to be the square root of 2 times y, so 2 times negative 1.81, divided by g is going to be negative 9.8. And you'll see that that negative and that negative are going to cancel out. So when I solve that, I will have the time she is in the air. Now I get to question 6. It says, what must be the horizontal distance between the saddle and the limb when the woman makes her move? In other words, how far is the horse going to go in that amount of time? So I want to know the x displacement of the horse while she's falling. Well, how far does a horse moving at a constant velocity of 4.6 meters per second travel in this amount of time? So what I know is time. I'm looking for my displacement. I have a velocity, and I know that my acceleration is 0 because this horse is moving at a constant velocity. So I do have an equation without a final velocity, or pretty much when acceleration is 0, I can say that distance is my average velocity times my time, or my constant velocity times my time. So how far will the horse move? Well, I'm given its velocity of 4.6 meters per second, and I can simply multiply that by this time, and I will get my displacement. That's how far the horse moves while she is falling, and this is how long she's falling.